Right. Greetings, young mathematicians! Welcome to Saxon Math, Lesson 98, Scale and Scale Factor! Okay, well...
Mr. Petrie, I came in late, and why are we doing the mental math? So I don't know why we're doing this.
Did you look at the stream this morning?
Oh.
Read the stream. Everything you need to know is there. Okay, so looking at our mental math, we can look at positive, negative 360 divided by 8. And so I can just look at this and just think, oh, besides I need this on black, I could think 320 plus 40 to get 40 plus 5 would equal 45, except for the fact that we've got our negative sign here. And so that means that we have a negative answer for negative 45. Okay, and order of operations exponents. So 2 5/10 times 4. Well, it's one of those questions of how many quarters are in a dollar. And so in this case, you've got 4 quarters, you've got a dollar. But since we are doing 2 5/10 and not 25, we could say 10 times 10. And then looking at our exponents, we technically add them together because we're multiplying them, but since we've got a negative 2, we are actually subtracting them. So that would get us 10 times 10 to the 5th power. However, that's silly because that's just another 10. So we could say 1 times 10 to the 6th power to say the same thing. And algebra! So 2c plus 1.5 equals 6.5. Well, we can immediately look at our 1.5 and our 6.5 and say, well, 6 minus 1 is 5, and then halves just kind of cancel each other out, so get very easily to 2c equals 5. Gets us to c equals 2, and since we're using fractions, 2.5. Measurement. So we're talking 2/100ths of a kilogram, but there are always 1,000 kilos or 1,000 units in a kilo. So we can just multiply this by 1,000 and go boinky. 1, 2, 3. Getting us 20 grams. Calculation. So 4 times 3 is 12. And spoilers, 3/4 of 4 is 3. You heard it here first. That gets us an answer of 15 with the trapezoid. And 33 1/3% more than 60, but 33 1/3% is just a way of saying 1/3. And I know 1/3 of 60 is 20, and 60 plus 20 is, hey, you be black, is $80. Okay, a centi is what fraction of any unit? basically. But in this case, a centimeter is what fraction of a meter, and you'd better say 1/100th. Please learn the metric system. And at 12 miles per hour, how far can Toby ride in 1 hour? Well, that's 12. And 45 minutes, which is 3/4. So 3/4 of 12 is 9, getting us an answer of 21 miles. Okay. All right, lesson 98, scale and scale factor. So remember when we were talking about triangles a couple of days ago and how two similar triangles will, you can end up with proportional sides and figure out the sides, do the proportions. So today we are taking that one step further to say that really that rule applies to anything. So, just jumping straight to example 1, a model airplane is built with a scale of 1 to 24. If the wingspan of the model is 18 inches, the wingspan of the actual airplane is how many? We're going to say that's W for width is how many feet? Just in case you're wondering, our graphics here are probably actually a scale of 1 to 12 because either the little airplane would have to be so tiny you couldn't even see it barely, or the other one would have to be so big that it wouldn't fit on the screen. So this isn't actually to the scale that they're saying here, just to be clear. Okay, so it's pretty basic how we go about this. So essentially you can just say 18 inches, and probably we won't even bother with the units right now. And so that will be times 24 because it's a scale of 1 to 24. So for every 1 inch, it's going to be 24 inches over on the larger airplane. However, we have a unit conversion where we're converting inches to feet. So in this case, we're dividing the entire thing by 12. So spoilers, that will be 432 inches divided by 12, which will get us to 36 feet. So we know that the plane is has a wingspan of 36 feet.
Mr. Petrie?
Uh-huh.
I don't exactly get what we were learning for this lesson.
We are taking what we learned about triangles, about how if you have two triangles that are similar, but they are of different sizes, but say what the proportion of two of the sides are, but say you don't have the information for what one of the sides are on one of the triangles, you can just use the proportion of the other one to figure it out. You remember that a couple of days ago?
Yeah, I remember.
So the point of this lesson is really that same rule applies to anything.
Okay.
So in our examples, they're trying to illustrate that by using miniature versions of actual objects. So in this case, we've got a model airplane that is identical to the real airplane in shape, but not in size. So we can use the scale of the smaller airplane to the larger airplane to do a conversion of what the wingspans are. Mm-hmm. Okay. We could also use a ratio box. And I'm going to just go for measure. And so our scale is 1 to 24. So say for every 1 inch of wingspan on our smaller one, we've got 24 inches on our bigger one. And then we know that this is 18 inches. And so what was the size of W? So we can do a little bit of cross multiplying with this, and well, essentially get to the same conclusion. So looking at that, we could write that out as essentially, or if I can find space, I guess I'll just write over it. W equals 24 times 18, and then that would get us to our 432 inches, and then we could do a unit multiplier action. Do a little bit of cross canceling here. Do a little bit of cross canceling here as well, and essentially get us to the same answer. It's 36 feet.
Did you get our power tool?
This is not a good time to ask me this because I'm recording this for YouTube.
Okay.
Since my other video isn't going to work. Okay, example 2. Sophia is making a model of a car from clay. But if you've got any questions about the actual lesson here, please, that actually make the video better. The scale of the model is 1 to 36. So say 1 inch on the smaller one translates to 36 inches on the larger one. If the height of the car is 4 feet 6 inches, then what should be the height of the model in inches? So, well, first thing we should do is convert all of this to inches, so that we're not working with apples and oranges. So we can multiply 4 times 12 to get 48 plus 6. So that'll get us 54 inches. And so maybe I'll just draw a ratio box here. We'll say scale, S for scale, M for measure. And so we know that our scale is 1 to 36. And our measure is, we're not sure about that, but it's to 54. So we can essentially do a little bit of cross multiplying goodness, which would get us to, I'll get this out of our way, which would get us to 36 times m equals 54, and so we can divide each side by this, getting us by 36, getting us an interesting ratio, but really it will come out to 1.5 inches. So if the scale, or if the height of the car is 4 feet 6 inches, or 56 inches, then the height of the car would be 1.5 inches. Okay, take a deep breath. This one is really simple, and really basically what you tell me almost every time I try to do too many steps in front of you. So if we're looking at something like this, sure, we could do our cross multiplying, but that really isn't necessary, since it's obvious to look there and see that there's a simple kind of scale conversion, is that if you multiply each side by 5, so 3 times 5 is 15, right? So we know that we can just do 7 times 5 equals 35. Ta-da! Which, every time I'm doing one of these and cross multiply just to show my steps, people remind me of that. So I know you know this.
So Pedro, are we still going to be able to do the practice set if we have time?
Well, the practice set, we do that in the afternoon.
Okay.
So this just sets you up to be able to do the practice set later.
What about the science fairs?
I'm not doing any this period. I'm doing this for you.
Okay.
Okay. Okay, so looking at example 4. So these two triangles are similar. Calculate the scale factor from the smaller triangle to the larger triangle. So also pretty simple. It's basically asking, well, what is our scale factor here? Like, what would you multiply any of the sides by to figure out the other? And so essentially we can just set up the problem as 20 times whatever the scale factor ends up being equals 25, right? And so we just divide each side by 20, which gets us 25 over 20, which gets us a 5:4 ratio, which still isn't very handy. So we could say that the scale factor is 1 and 25/100ths, or we could say that the scale factor is 1 and 1/4, or we could say the scale factor is plus 25%. Okay, example 5. So a lot of steps, but none of them are really that tricky. And also, a cool thing is this totally reminds me of the Size of Life video, in a nutshell, Size of Life. And yeah. This is a perfect illustration of the idea that every dimension that you add when you are increasing in scale doesn't just increase the mass by whatever you're increasing it by. It increases it by levels of magnitude every time you add a dimension. So hopefully that's not too big of a mouthful there to explain something fairly simple. But so if we're looking at these two rectangular prisms, and so dimensions by 2 by 3 by 4, and the larger one is dimensions by 6 by 9 by 12. So what would be the scale factor from the smaller to the larger rectangular prism? Well, basically, I think what they're meaning here is the edge. So what is the scale factor for just one edge? And so just looking at what we did before, so 2 times the factor equals 6. So the scale for the edges is a scale of 3. So we can look at the other some of the other sides and see that that's true. So yeah, the 3 centimeters here times 3 gets us our 9 centimeters there. So all good. But what happens if we take that to the next level and are talking about the face or the side? How will that work out? Okay, so now looking at that, we could say 2 times 3, and since we're talking centimeters, 2 centimeters times 3 centimeters will get us 6 centimeters squared. However, 6 centimeters times 9 centimeters will get us 54 centimeters squared. So looking at that, we can see that it is actually a factor of 9. So looking at this, essentially a line, I guess one-dimensional, will be a factor of 3. Two-dimensional will be a factor of 9. What do you suppose three-dimensional will be?
27.
Yes, because we're increasing by one exponential factor each time, right? So, taking that in mind, let's take this to the final level here and talk about the full volume. So now we've got 2 times 3 times 4 will get us 24 centimeters cubed, and 6 times 9 times 12 will get us 648 centimeters cubed. And so if we do the division for that, we'll get a factor of, as our friend said, 27 for the volume. So absolutely correct is that things increase by essentially one full level of magnitude, one full exponent each time we increase a dimension. Okay, I'm going to stop my recording.